So it's my pleasure to introduce the moderator of our first panel, Dr. Elizabeth Carlson. She is a professor of medicine at Harvard Medical School, a rheumatologist and epidemiologist at Brigham and Women's Hospital, principal investigator for the Mass General Brigham Biobank, and many other multi-institutional programs, including the NIH All of Us program. She will be leading a group of panelists that are representing biobanks on several continents for this panel. In our first panel, Biobanking Around the World. Welcome, Dr. Carlson.
Thank you very much. Can our panelists come up and have a seat? Okay. Great. And hello to the online audience as well as the audience here in the auditorium. I'm delighted to be here today to host and moderate this session on biobanking, biobanking across the world. And our session will focus on speakers who represent large-scale studies in the UK, in China, Estonia, and in the United States. These biobanks are designed to collect samples for genotyping or sequencing of the samples or for other biologic assays, along with lifestyle, environmental, and clinical data to analyze risk factors for chronic diseases. But also, many of the biobanks collect really deep phenotype data, phenotypes that come from electronic health records or from extensive questionnaires or from testing, such as bringing people back to get pulmonary function testing or MRI scans of the brain. And so this deep phenotype data is incredibly useful for analyzing genotype-phenotype relationships. But also, this data can be combined across the world to do multi-institutional, multi-biobank, and cross ancestry studies. And if we've seen over the last 30 years, the genetic data that has come from the biobanks has been utilized to make really important discoveries about human disease pathology, about gene-environment interactions, and about potential pharmacogenetic variants that can be targeted to develop precision medicine and precise medical therapies to improve human health. But there are lots of challenges of establishing biobanks, and we'd like to talk today about what some of those challenges are, how some of our lead investigators here have addressed those challenges, but also what the remaining challenges are, particularly in the aspects of representation of the world's population in the biobanks so that we can really discover novel treatments and disease pathophysiology for everyone in the world, not just from the most populated, wealthiest countries. And so with that brief introduction, I'd like to just tell you about how the session will go. We will start with a brief overview from each of our speakers about their leadership role in their specific biobank, the study design features and unique aspects of their data sets. They'll discuss technical and social challenges to biobank design and implementation, how they manage competing priorities between recruiting more and more participants versus doing the deep phenotyping that I described. And importantly, we'll discuss the historical issues with representation of mostly European ancestry individuals in genetic studies across the world, although that is improving, and ways to address this representation of the world's population in future biobanks and in expanding the existing biobanks. So our panelists, I'll just start from right to left. We have Dr. Naomi Allen, who's the Chief Scientist for the UK Biobank and a Professor of Epidemiology at the Newfield Department of Population Health, University of Oxford in the UK. Dr. Lily Milani, who is head of the Estonia Genome Center and Professor of Pharmacogenetics at the University of Tartu. Dr. Zhongming Chen, who is the inaugural Richard Peto Chair in Epidemiology at the Newfield Department of Population Health at the University of Oxford, and Dr. Keolu Fox, who is co-founder of the Native Biodata Consortium and an assistant professor at the University of California in San Diego, where he also co-founded and co-directs the Indigenous Futures Institute. So why don't we start with Naomi Allen? Could you give us a little bit of an introduction to you and your biobank?
Okay, great. Thank you. So hello, my name's Naomi Allen, Chief Scientist for UK Biobank. And I really just an overview of UK Biobank, a lot of people, when you talk about UK Biobank, think of it as being actually just a glorified freezer where we bank samples for research purposes. But the reality is that it is so much more than that. So really, UK Biobank has four main properties, I think, that makes it a pretty unique resource in the world for doing public health research. The first is its size. So we recruited 500,000 participants about 15 to 20 years ago across the UK. And we collected an awful lot of data on all of these 500,000 participants. Genetic data, lifestyle factors, physical measures, biomarkers, and so on. The third is the duration of follow-up. So in the UK, we're able to link to all 500,000 participants' electronic medical records, and we have done so over the last 15 years. So we have complete, comprehensive information on deaths, cancer, hospital admissions for all sorts of diseases, and now in really robust research into public health. But perhaps actually the most important criteria, it's all well and good building a fantastic biobank, but you really need people to use it. So UK Biobank was set up on the premise that it would be easily accessible to both academic and commercial researchers worldwide to perform health-related research that's in the public interest. And we now have over 30,000 researchers over the world from over 90 countries accessing UK Biobank to make scientific discoveries, not just in genomics, but in imaging, lifestyle, etiology of disease, but also risk prediction and progression of disease. So I'll leave it there. Thank you.
Dr. Milani.
So thank you for the invitation. It's a great pleasure to introduce the Estonian Biobank here as well. And I would also like to just praise the UK Biobank for setting such an amazing standard of data sharing and data access across the world. It has really been crucial for advancing science, which is our ultimate goal here. And regarding the Estonian Biobank, we are a population-based, volunteer-based biobank in Northeast in Europe. And I'm waiting for the slides to come up. But the setup is maybe most similar to UK Biobank. And so we have recruited 200,000 individuals, which is about 20% of the adult population in Estonia. And I don't know, it's not working. So, and all 211,000 have been genotyped, and 3,000 have whole genome sequencing data. But the electronic health records are extremely rich, since we have a single payer health insurance across the country. And their primary care records, specialist care, laboratory measurements, all are stored in one central eHealth database, and that is what we have access to for the research as well. And what has been crucial in founding this biobank has also been the Estonian Human Genes Research Act, which regulates all the work related to the biobank. Participants have signed a broad informed consent for updating their health records and data from registries, anything related to their health annually. And it's also open for research, and we're also learning how to share data more broadly internationally as well. What is unique about the Estonian Biobank is that we have put communication and engagement with the Biobank participants in a very central place. So whenever we have a publication coming out, we have a lot of talking about it in the media, but that has also been supported by recall studies where we can return results to Biobank participants. And this has been mostly starting with rare monogenic findings, or more common monogenic findings such as familial hypercholesterolemia, familial breast cancer. So based on genetic findings, Biobank participants are invited to participate in studies where they can receive results. Once they sign an additional consent form, that is when they can then participate in the study, and they get genetic counseling and are guided to an oncologist or a cardiologist where the follow-up is done. We also have had ongoing clinical studies recontacting Biobank participants with high polygenic risk for breast cancer, high polygenic risk for coronary artery disease, and at least the one for breast cancer has been very successful in identifying a much higher proportion of early stage breast cancer findings in individuals with high polygenic risk compared to what we would find with regular screening programs. So yes, this is our introduction, and open for discussion later.
Thank you very much. And next, we'll turn to Dr. Zhangmin Chen from the Kadoorie Biobank.
Can I have my slides, please? Thanks very much for the kind invitation. So I'm going to give you a brief overview of China Kadoorie Biobank. Again, this is established in collaboration with scientists in China. It's designed and planned from Oxford in the same buildings as Naomi. In terms of the size, it is the world's largest population biobank ever established in non-European ancestry population. So this is very important. So I think it has been almost 30 years in the making, with great potential, but also it comes through various challenges. It doesn't really work. Okay, got frozen. Okay, yeah, that's fine. I think they come from all kind of different aspects. Some are scientific, social, and political, and legal as well. So at different stages, you have to plan, you have to coordinate very carefully. I think some are expected, some are totally unexpected. For example, geopolitical uncertainty for long-term collaboration, data sharing of genetic data. This is one of our major challenges we're facing now. I think it's been I thought it's a long march with ups, downs, and with some magic moments. But it took us 10 years to get funding. We started to plan the study during mid-1990s, but people thought we're crazy. The typical study is like Framingham study, 5,000, you want to do 500,000, no scientific kind of justification or scientific hypothesis. Just collect samples, data, put away, and wait for technology to develop. But I think we just have a almost religious faith. We believe this is the way forward for epidemiology. We just keep trying. Eventually, we managed to secure some funding from Kadoorie Foundation in Hong Kong as a kind of a starting grant. But I think, I don't have time to go through, but I think overall study in an excellent shape. There's still a lot of challenges, especially how to turn sample into the data, like what have been achieved in UK Biobank, whole genome sequence, metabolomics, proteomics, chronic infection biomarkers as well. So together, these two studies will make huge impact. So I think we have managed to overcome all kind of challenges in study organization, in scientific technical sort of challenge as well. So in case people are not quite familiar with, the study cover 10 carefully selected areas in China, freezing north in Harbin to tropical south, from coastal cities to inland and rural areas. So each site is probably 10 Framingham study with 50,000 recruited, but they use standardized protocols. Everything done electronically, no paper involved. So the baseline survey took place during 2004 and 8. With less than 4 years, we managed to recruit on target, on budget, over 500,000. Slightly bigger than UK Biobank, deliberately, with 512,000. A lot of questionnaire, physical characteristics, but most importantly, blood samples. And ever since, we have conducted 3 periodic reach surveys. Ideally, you want to do all 500,000, but we've managed to do at least a random subset with a lot of enhancement. In recent years, we started to apply the latest technology. Proteomics, for example, recently we completed Olink assay 3,000 proteins and Serologic 7,000 proteins. And now the plan is actually to apply this to all the blood samples stored in Oxford, in China, as UK Biobank. But one of the most important things, which is way beyond what we initially envisaged, is that we're able to link not only mortality, but any episodes of hospitalization. So this is a greatly increased study power, improve the quality of disease diagnosis, but also enable us to study many non-fatal conditions, such as, you name it, we capture several thousand different conditions, including earthquake, including snake bite, including retinopathy, autoimmune disease, dementia, Alzheimer's disease, as well as the cancer, stroke as well. But they're all very well characterized. So I think we have, released the data several years ago. We're now in the process of developing cloud-based system modeled on UK Biobank, try to make the data more widely available, especially genetic data. But I think we have a lot of good publications. Some actually just confirm what you know, but fuse evidence gap in China. Some actually very normal. Some actually intrinsically unexpected. My favorite one was alcohol, whether moderate drinking is protective. I'm not going to go to that one. That could be half-hour talk. So this is a huge undertaking, but so far it's been a great success for us, thanks to careful planning and also a robust system, infrastructures. To share our knowledge, we have published a book a couple of years ago. It put together our methodology, our thought process, and including the development IT system, which is critical to enable the smooth continuation of the project. So I'm going to stop here, but this is a huge collective effort. I'm looking forward to the further discussion. Yeah.
Thank you very much for that introduction. Dr. Fox.
All right. Okay. You guys can hear me good? All right. Aloha kakahiaka. And first, I just wanted to say thank you to Sam, Raj, and Zach for having me and having all of us and having this lovely discussion. I'd like to kick off my slides. Here we go. All right, if you'll look on the left, I won't use that much data today just because I know we have a lot of clinicians in the room, okay? But on the left, you'll see data from Melinda Mills' GWAS Diversity Monitor. And you can see that there's a disproportionate amount of genomic studies that feature individuals of Western European ancestry. And this is from this morning, just so you know. On the right, I think the more concerning statistic is that 72% of genetic discoveries have taken place in 3 countries on planet Earth. That's the United States of America, the UK, and Iceland, oddly, but we know Carrie Stephenson and Decode and all of that, which means that the majority of people are outsourcing their genealogy, their genomic information to a number of different places. And that just doesn't sit well with historically marginalized communities for the most part, especially not in 2023. So when we add on top of that the actionability of intellectual property, and here this is at Illumina's headquarters in La Jolla, California, and on the wall you see an endless number of patent claims. And it vaguely resembles a hunting lodge where you'd see moose heads, right? But I think it's really important to understand that, at least 45,000 patents have been filed that mention genome sequencing or genome sequencing data. So this data is extremely valuable and it's being commoditized. And this is before the pandemic, these results. Now, This is both an installation and a collaboration with NVIDIA for a data center that we've created in an old bank in Hilo, Hawaii. Anyone ever been to Hilo? Okay, my man. All right, me and you, brother. But check it out. This is, a display. So we like to have our community walk through and kind of understand how data is stored. We want them to feel the heat coming off the servers. We want them to hear the sounds. And we intentionally put it in a bank. And the reason is because we want people to understand how valuable that information is. Because data has surpassed oil as the #1 most valuable commodity on planet Earth in 2018. So we need to start thinking about data as a resource. And that's how we educate our communities. Those are the principal components of how we build and design infrastructure around biobanks. And we're taking a much more federated approach rather than a centralized approach. Because the pipeline that we're observing in genome sciences is broken. There is not enough ownership and actionability on patients and on the community level. And I'm pointing here to Cobalt because Tim Cook the other day got up there and said that their new watch is carbon negative, and that's bullshit. And I don't want our pipeline and our supply chain in genomics to resemble what's going on in Apple. That's why we created these fake images, deep fakes of Tim Cook visiting the Congo, because he's never been there. He's not in touch with his supply chain, and neither are our patients when it comes to genomic information. And that's why data sovereignty is so important on the education level. We are focused on vertical integration of technologies to empower our communities, just like Ford did with the Model T and buying plots of land in the Amazon to grow rubber plants, every single component, just like Amazon Web Services does as the most powerful and influential company in the world, storing your data. We have begun to develop this infrastructure locally through the Native Biodata Consortia on Cheyenne River, about 2 hours away from Standing Rock. This is the first biobank and genome sequencing center on a reservation in US history. These are some of my colleagues. We also started Variant Bio, where we give 4% of our proceeds back to community members and free access to drugs. We just finished our Series 3 financing, and we're doing great. Please check that out. Hopefully that goes public. And in terms of the way we're collecting information, we are really focused on point-of-care technologies. This is a Myoton, actually developed in Estonia. And it's a way for us to de-black box technology and the collection of phenotype information in some of the most remote places in the world, like this giant gout study we're doing in French Polynesia. And decentralization, I think, is the way forward, and focusing on bringing some of the most elegant tools for precision medicine to community and practicing and building that infrastructure locally. And I'm happy to talk about that. Thank you.
Thank you. That's really fascinating and very different from how others have built their biobanks. So I look forward to hearing more during our panel discussion. Okay, so I have some questions for the panel, and we can maybe have volunteers to answer, or I can call on people, however you would like to do this. But I wanted to ask you to think about when you started your biobank. For some of you, that was many years ago, as Zangmen said. It was 30 years ago, did you say, that you started planning? So when you establish a new biobank, are the challenges primarily social, or are they primarily technical? And what about when you're growing your existing biobank? Does that shift between the social and the technical happen? I assume you have to get buy-in from many different levels. Say you're starting a new biobank in a country that's never had a biobank. You have to get buy-in from everybody, from local leaders up to governmental leaders. So there must be a lot of social challenges there. You have social challenges with getting participants to be willing to join and to trust you. As Kealu said, trusting that the data is safe and that it's stored in a bank and that it's very safe and protected, right? That image of a bank is helpful, and probably that's why these are called biobanks, right? To give the participant the sense that this is a safe place to store their blood and to store their genetic data. So maybe we could talk a little bit about some of the longer-term biobanks and then some of the more recent ones. So Naomi, would you like to start off maybe about what the challenges have been?
Yeah, sure, thanks. Well, I think the challenges are obviously both social and technical challenges, but both for establishing the biobank and keeping the biobank on the road over the next few decades, because that's how long these studies need to be maintained in order to follow up the participants' health over time. I think that the social challenges is actually more pressing. In UK Biobank, we've put a lot of effort into making sure that all of the 500,000 participants who joined the study know exactly what we're doing. They're a very altruistic bunch of people. They don't have any, there's nothing in it for them. They're doing it for the future health of, future generations. So keeping them on board that what we're doing is sound and ethical, they can trust is hugely, hugely important. And that's also important not just for the participants, but also for the public and also ultimately for the funders. So I'll let others chip in, but I think certainly the social aspects of establishing and keeping a biobank going are actually probably more difficult and certainly more resource intensive than the technical ones.
Zhangming, do you think has that been your experience also?
Yes, I agree entirely. I think it's multidimensional. But for me, in terms of Kadoorie Biobank, I think the big challenge is the political and the various stages. For example, once we did manage to sort out funding, it took us over a year to get the approval from very highest level Ministry of Health in order to be able to roll out and to get the plasma sample export to UK for long-term safe storage as well. I think the technical is another thing. Scientifically, you need to be really patient. Maybe people now at different stages at the time. I don't think we were ready to do any large-scale assays. So our approach was, get the 500,000 recruited within 4 years and store the sample. Don't really touch it. We don't want to do large, very small-scale assays. We actually have a phase, technology will get there. And now it's almost there in terms of genotyping, whole genome sequence, proteomics. I think they require very little amount of sample, but they're still quite expensive. So I think there's issues, what would be the best time to do and how manage to secure this kind of funding. So I think for us, the trouble is the study is a bit too big. Even the assay costs like $10, you need 50 million. Yeah. So,
right.
But I think we will get
there. So there's also a challenge in deciding when is the right time to pull the trigger on doing a test, right? Where is the price coming down gradually? Will it suddenly drop next year because of some new technology? So that's a technical challenge.
Yeah. So we've done a lot of pilot studies to understand technology, try to keep pace with different technologies, companies working, develop good relationship, and then try to identify potential funders, private, public,
right.
as well.
Right. And are there social challenges with sharing the data when you work in another country?
I think for the genetic, yes. This is still issues we try to turn around. So maybe we will go to the cloud-based system. The data do not leave, the research facilities. Mm-hmm. But with the non-genetic
some people call that a passport system, where you come to the data and analyze the data on an enclave that stays in the country.
Yeah.
So that's what you're thinking about.
Yeah. For the non-genetic data, we started to share several years ago. So we got not as many as 30,000. We probably got several hundred researchers registered. So we have delivered some data. So I think this is a perfect, moment to advertise a bit more what we are able to share to do, in the coming years.
Kiala, would you like to comment?
Oh no, it just sounds like a federated learning problem, and it's a lovely entry point for some new algorithm development. We recently published a paper on this in Nature Machine Intelligence, if anyone's interested. I could tell you about the most recent kind of biobank that we're building with Queen's Health Systems in Honolulu, which is the largest service provider for healthcare in Hawaii and the Pacific Rim broadly. And I can tell you from experience, we're doing a whole bunch of focus groups. I don't know if anybody's ever done that. It's a very interesting experience. But what we're seeing is that our community is not really into financial support from the federal government, because those are the exact same people that stole our land in the first place. And so there's a lot more interest working with, hand in hand with private industry. And I think that's a kind of departure from the status quo and definitely the future.
Interesting. And Lily, you have an astonishing percentage of your population who've joined the biobank, 20%. Can you tell us, how you got to that point from a social aspect?
Yeah, I think regarding the social aspect, it has been really important to engage with the people on a daily basis, which is maybe something scientists are not used to. And just getting out of your comfort zone and talking to the media after each paper, or it doesn't have to be a paper published by our biobank. It can be a discovery from the US or China or UK. And just explaining what these things mean and how it can be used in the clinic, and explaining a lot around what is actually, it's not like we now have a gene for educational attainment. Do I have this gene? But really a lot of education that needs to be explained around all of these polygenic features. But I think also what has been important is building trust. Like Naomi mentioned, that trust in the data is safe, it stays here, it's de-anonymized or pseudonymized, and that your identity is secure, the data is stored in secure servers, and the place where the individual level data is does not have an internet access, and very simple language, and explaining all of this, and the legal structure around all of it, that what the data can be used for, what it cannot be used for, not for any crime reasons, not for any insurance purposes. So yeah, trying to build trust.
So it's a combination of sort of communications through the media and promoting the study across the entire country. That has worked well for you?
Yes, and for reaching 20% of the adult population, we really needed to make a bit more promises. So it was not only altruistic, it was storytelling by people who had received their results.
Right.
For example, about finding out that she had higher risk for breast cancer. And journalists could be quite provoking, that don't you regret finding out about this? But right. I think the research study participants were amazing. They're explaining, no, this risk was already in me. Now I'm aware of it and I can do something about it. So they were helping us to educate the people as well, and really change attitudes.
So that's interesting. So, often in medical research, we rely on altruism. We rely on our participants to join because they will help future generations, help us discover genetic discoveries that can help their children, for example. And that's the premise of the UK Biobank. But you chose a different course, which is to start out from the outset planning to return results. So is that more of a value to participants, to actually get something back other than just the feel-good part about donating your samples for research and your data? What do you think, Kealu?
I'm familiar with this. Is everyone familiar with the greater good argument? Okay, cool. It's a basic philosophical argument that's often made in these settings. And I think a lot of people from historically marginalized communities are more concerned with the whose greater good are we referring to. And so when we look at the way this data articulates with our creaky, broken, or broken by design healthcare system, we have to look at what that means when you put data that's this valuable into an open data environment and you act like it has to be binary. It's either open or it's closed. It's black or it's white. And what happens often is these data sets get driven over the goal line by the Regenerons of the world, or just to pick on those guys. Is everyone familiar with Vertex? It's here in your backyard. So when they debuted the Precision Medicine Institute, then the good days, President Barack Obama was talking about the actionability of mutations that were discovered for cystic fibrosis. This was like the kickoff for the All of Us program. What they didn't say was that Vertex worked directly with the Cystic Fibrosis Foundation, sequenced patients' genomes, identified new actionable intellectual property, developed a new drug that was highly efficient, and then put that drug on the market for $300,000 a year. So we have to look at that and say, that's deplorable, that's a violation of the common law. And if large-scale government initiatives like All of Us, which we're all paying for, aren't worried about the rest of us, we have a major issue. And I just wanted to bring that to everyone's attention.
Interesting. So the value is really important when you're talking to your participants, when you're advertising the study, when you're creating the consent form. What is the value to the participant of joining this study and putting themselves out there, sharing their personal health records, right? Sharing all the details on the questionnaire, sharing their samples. And, dating back to Henrietta Lacks, who shared her samples without informed consent, a lot of profit has been made from those samples over the years. So I think it is important in designing a biobank to think about that and think about what you'll put in your consent form about future profits that can be made off of the discoveries. So is there another value proposition that you can think of that we could be offering participants? Are there other types of information they could get back from your biobank? So in the Framingham Heart Study, for example, this is a longitudinal epidemiology study in our backyard. Framingham's very close to here. Participants get exams every couple of years, echocardiograms and EKGs and so forth. They get all those results back. They can be used clinically. So are there other deep phenotyping assays and studies that are being done, for example, in the UK Biobank? Are these being returned to participants? Or are they just for research?
We don't feed my microphone. I'm not sure my microphone's on. We don't feed anything back. And we're doing a sub-study whereby we're imaging, performing MRI scans of 100,000 of our participants. There, because they're in a scanner, we have a duty of care. If a radiographer happens to spot something they think is life-threatening on the scan, we will write to them and their doctor and say, you might want to check this out.
So if you find something that's clinically actionable.
Exactly.
So there is a benefit to them if something is discovered.
I honestly question whether there is, because in 3/4 of those cases, 2% of participants, the radiographer will spot something they think is potentially life-threatening, a brain tumour or an aneurysm or something. They'll feed that back to them. They'll feed that back to the participant and the GP. It causes an immense amount of anxiety. Oh my God, I'm going to die. They're going to have lots of further tests, operations, procedures, further MRI tests at all costs to the National Health Service. And in less than half of those cases, will it actually turn out to be something clinically significant and life-threatening. So in our experience, actually feeding back results that you think could be really clinically relevant, it does open up a bit of a Pandora's box. And
it is really important.
Yeah.
I mean, to go back to the basic principles of epidemiology, if you give back a result that has a high false positive rate, you incur a lot of harm.
Exactly.
Right?
Exactly.
And so that's what we need to really think about when we're considering what to return. What's the background population prevalence? Is it a very, very rare finding, which means that a false positive rate will be very high. No matter how high you get your sensitivity and specificity, the false positives will really outweigh the true positives. So for those of you who are students in epidemiology, that's a basic principle to think about when you're thinking about returning results. But it seems to me that it is a motivator beyond the motivation to contribute to science. So another way of feeding back information is to feed it back on a group level, right? To make sure the participants hear the findings that are being discovered from the research, as you're doing in Estonia with all the news media articles. And so it must have been kind of frustrating for the China Kadoorie participants to wait all these years for results. Have you heard feedback from your participants?
I think we have a very similar approaches as in UK Biobank. In our written informed consent, we made it very clear. So any future tests, whether it's genetic or some other assessment, we're not going to provide because A, we don't know what we're going to do down the line. It could be 5, 10 years. And B, we don't know what's the implication at the individual level. So, but I think at the baseline and a subsequent periodic resurvey, we did provide some kind of feedback on the questionnaire, like if you smoke, we provide them with a very detailed booklet, health education leaflet, and also some risk prediction model developed building on the Kadoorie Biobank. Just try to provide a bit more information based on the knowledge generated information generated in the study. Mm-hmm. So that's, and of course, when we have a study findings, we try to do a lot of PR campaigns as well to inform not individual level, group levels, media, and the policy as well. So this is actually the way we.
I'm curious, Kealu, have you, with your focus groups, talked to people, the real people on the street? What do you want to get back from this study?
Yeah, that's a great question, and obviously that sort of response varies. I can tell you one thing, it's really, when you educate people on the potential use and misuse of something like genomic information, it tends to skew the potential for them signing a consent form. And so I think we all know what we can say to people to convince them to, part with their genetic information. But I think one real tremendous way to incentivize participation is benefit sharing. Has anyone ever heard of this? Could I see anyone's heard of benefit sharing? Anyone in the crowd? Okay, it's a relatively new idea, but this is the sort of, principal component of Variant Bio. And again, it really changes the playing field if you're willing to give percentage of royalties or profit back to a community for participating in a study.
Interesting. It'll be interesting to watch to see if this catches fire.
Well, I hope it's as disruptive as we know it is. Yeah.
Wonderful. So let's move on to another question. When you're designing your study and planning over the years what you will do with growing your sample size versus expanding the technology, the testing, the types of omics that you'll do on the samples, how do you balance that as sort of a competing demand on your budget? Because recruitment costs a lot of money. Collecting the samples, storing the samples costs a lot of money, but so do all these assays. So I'm interested in how you can balance that. Go ahead, Kealu.
Oh, again, operating in America is so different from the UK where you have universal health care. I'm not familiar with Estonia, but for us, it's really about insurance carve-outs. It varies from state to state. You have to think about the Indian Health Service, and that is quite complicated and underfunded as far as everybody, as I know. So it's really about being clever about what will the feds subsidize. Will it be complete exome sequencing, a whole genome, an array-based study? And I think maybe that's like the job of politicians in Washington, D.C. to have a little more influence on what we can actually do for patients.
I think when we started Kadoorie Biobank, I don't think this is a major issue because we're given a very small kind of a set budget. So we actually designed study according to what was available at the time, timeline, design the study. So it's not kind of driven by scientific curiosity, you want everything because that probably costs a lot of money, it's not sort of achievable. So I think that's quite important. Very often you're against the timeline, with the constraint of a budget. So I think, for example, in our study design, we didn't collect deliberately detailed dietary information because that could costs a lot of money. You probably spend hours, especially Chinese diet, just so complicated. I just couldn't answer the questions myself. So we just leave it, with a very high level food group, for example, try to. But overall, the key things is actually biological samples. And then now, I think if you start studying now, that's probably different settings. Genotyping sequence is just so cost effective. So you may want to do in parallel. But for us, we just recruit 500,000 within 4 years.
For the UK Biobank, was the initial targeted sample size 500,000, or was that adjusted over time depending on budgeting?
It was 500,000 because that was what we could afford with our budget at the time. And our approach, our kind of mantra was defer as much as we could. So we collected what we could in a 2.5-hour assessment visit. And then we kept the biological samples in storage, as Zhengmin said, is for China Kadoorie Biobank. And then once the data was made available, then researchers around the world recognized the value of these data. And then we're like, okay, wouldn't it be great if we had whole exome sequencing, whole genome sequencing, metabolomics, proteomics, and all the rest of it? And then they have come together and invested to do all of these assays on the full cohort. So that has been our approach, and it's worked very well.
And how about in Estonia? Seems like you do have a mix because you're doing some sub-studies where you're actually doing the assays now.
Yeah, but I think it's the same, to try to keep a focus, to really start with recruitment and then put full focus on recruitment, to bring the costs down as much as possible. So if we recruited 100,000 people in 9 months, we had people out in pharmacies, shopping centers, concerts, like we have the whole infrastructure in place to recruit people throughout the country. And then you close down that shop, and then you start exactly the same way, finding partners for deeper phenotyping or proteomics. Now we have just finished doing metabolomics for the whole biobank. And our precision medicine program is a bit the poor man's precision medicine program. So our budget was 50 euros per sample. That was including recruitment, genotyping, and generating final reports.
That's not very much money.
No, but we did it.
Good for you. Interesting. So let's circle back to what we started off thinking about, which is how do we get samples from people around the world to improve the representation in genetics research? Because as we saw on Kiela's slide, most of the data has come from 3 countries, right? And 95% of people from European ancestry, and we know when there are large studies in other populations that unique findings can be found that are very, very relevant to the health of people in other parts of the world. So to me, that's the biggest challenge in biobanking now, is how do we take the resources in the resource-rich parts of the world and share them with the resource-poor parts of the world? How do we choose the countries to focus on? What's necessary? That's one question I would have for the panel. Do you have to have an electronic health record that's sophisticated so you can get the data that way? Can you get the data in other ways? Who would like to take that? I'll leave that open and people can volunteer.
Shall I make a start?
Sure.
It's absolutely crucial that we have strategically placed longitudinal studies across the world in different genetically diverse, ethnically diverse, racially diverse populations, because as we all know, white Caucasian populations have been done to death. And you need to generate those polygenic risk scores and all of the other, including the lifestyle associations as well, in those other populations. So the issue, I think, is that it comes down to money, and it comes down to capacity building, having the skill sets in those countries. We collaborate with colleagues in India, doing a 200,000 study in India, and they go around house to house to collect information on who's died, what did they think they died of, because there aren't no death certificates. So it's just very, very challenging for all sorts of reasons, but it's absolutely crucial.
Zhangming.
I think that this kind of a biobank in diverse population, is crucial for the development of precision medicine. Because of a different lifestyle effect, different disease rate, different genetic architecture. And also a lot of study findings can inform disease prevention treatment. For example, in China, the mean cholesterol was very low. So this is really help you to understand what's the biological normal cholesterol levels. And also high proportion of Chinese adults, including myself, we carry this fracture gene. So this is actually perfect genetic defects, help to assess whether moderate drinking is beneficial. Using Mendelian randomization, it cannot be done effectively. So there are a lot of this kind of scientific justification. But the real challenge is, as Naomi mentioned, is actually this is a long-term study. Money cannot solve all the issues. I think very often if you want to study a big study which is going to last 20, 30 years, you should always start not from recruitment, but from the long-term follow-up, whether you're able to follow them up. I think this is whether you're able to link to
So
the...
in other words, you don't want to do just a cross-sectional study of sampling the population once.
Yeah.
Because
you don't want to
you need the health outcomes over time.
Yes, yeah. I think we're being very, very fortunate, just perfect time in China when we started. Initially, we saw we can only link to mortality, but now we're able to link any electronic health record. So this is greatly improves the power of the study beyond what we initially envisaged. So in a way, we're just very lucky.
So how do we choose the places to invest? H3 Africa is collecting genetic data across Africa, but there are other parts of the world, like the Middle East, that doesn't have a lot of genetic data yet. Some studies are coming out now from the Middle East. Kalu?
Yeah, I think there's kind of two really interesting components here. One is we just speaking from the point of view of the United States of America, we need to work in diverse places. So where we establish studies and build cohorts, what are the most diverse cities and places in America? The most diverse, technically, and this is according to the new census information, the most diverse county is Hawaii County. The highest rates of admixture in America. These are really complicated places to work and roll out precision medicine. We have high rates of admixture. We are going to have all kinds of problems with efficacy for pharmacogenomics. It's a fascinating population genetics question and problem. Places like Houston, Los Angeles, the Boston metropolitan, New York City, great example. So those are really, really, just really focusing on serving those communities. And I think there are a lot of incredible scientists and clinicians that are really focused on that. Then secondly, on the other side of the coin, it's really hard to understand population genetics unless it's in context of geography itself. So we are Darwin's finches in that sense, high elevation adaptation, the effect of transoceanic voyaging in Polynesia and how that shaped our genomes. These are the reasons I got into population genetics, so that we can understand these just beautiful insights into evolutionary biology and, in effect, the impact they have on the medical level mechanistically. They're just fascinating, incredible stories. And I think we probably need more of the latter. We need hyper-focused studies that are really prioritizing understanding mechanism instead of correlation-based, large-scale, genome studies, large science, in my opinion.
Interesting. So why don't we open it up to questions? We have an online audience too, so I invite you online to put in your questions and we'll read through some of those.
No. Oh, there we go. My name is Aaron Abend. I run the Autoimmune Registry, which is a nonprofit. I try to get people into clinical trials. And one of the things that's clear is that most people, we talk about research and the health system. We understand the division and how they're separate. Most people have no idea. And that's the problem. I think that there's a concept of a learning health system, and maybe places like Estonia, which and the UK, where you've got the centralization of both the health system and the research, you might be able to do that. But that's what we need to do in the US too. We've got to figure out some way to get the health system to be part of the research enterprise, Do any of you have some insights into how best to do that?
I can maybe just share from Estonia what we've realized is that the people actually don't really distinguish between the biobank being a research project and the healthcare system, so they kind of see it as one. And it's an advantage for us because legally there are so much more obstacles if we would like to call this clinical medicine, whatever we're doing. But it's research projects, and we're returning the results as part of research studies, and they're getting to even their pharmacogenetic reports, for example. All of this is returned with great disclaimers. This is research reports, and they are part of a study where we're evaluating how you understand it, what feelings it generates, and so on. And of course, the cardiovascular or cancer ones are more specific, but I think it's kind of a loophole that we have and we should use. But yeah, definitely more broadly, we should figure out how to connect them better and in a more clinically acceptable way.
Thank you. How about the next question?
Well, thank you so much for this. This has been so insightful and so many questions, but I'll try to keep them brief. But before my questions, I just wanted to give a shout out to you, Kiolo, for saying it as it is. And I think we need more scientists who are active in science policy. So all the young people in this room, you know, this is a very important career if you're tired of academia. My questions start with especially the people in very homogenous countries like the UK, for example, lots of immigration, as opposed to Estonia, where I think there isn't a lot of immigration. And so the messaging is much easier, the convincing is much easier. How deliberate were you in enrolling diverse people in your studies, or was it very much university students who already come from very privileged backgrounds, and so you're re-establishing the same issues? That's my first question. My second is also to people in Europe, GDPR. How has that changed your sharing with non-European countries, and how do you think about it? And what do you think are the benefits of outsourcing informatics, say, to a country like India, versus keeping it all very local, and how you think that might impede progress in a way?
I think we could go for an
But
hour
that
on
would,
just
yeah,
those topics.
Those two are, yeah.
So
Thank you so
maybe,
much.
Naomi, do you want to take that?
Yeah,
just
so
quickly?
for UK Biobank, so at the time of recruitment, which was 2006 to 2010, we deliberately tried to recruit in areas across the country that were ethnically diverse. So areas around London and Birmingham, major cities where there were lots of ethnic minorities. And at the time, we recruited about 5% of the population who were from black and ethnic minorities, which was representative at the time of the UK. It's not anymore. So we're absolutely not the best cohort to study differences across different ethnic groups, but it was the best that we could do, and we deliberately tried to oversample. But it's different, and we tried to recruit the general population within a certain age group, and we just wrote to everybody who lived within a 30-mile radius of one of the assessment centres and said, come along. So there were no other eligibility criteria.
And then the GDPR aspect.
The GDPR aspect hasn't changed the way UK Biobank operated, because we were already operating well within GDPR. Although what I would say around that whole area is that for the genomic exome and genomic sequencing data, that is only available through our cloud-based online research analysis platform. So we don't disseminate those data to researchers, which we do with the other lifestyle and follow-up data, but the genomic sequencing data can only be accessed on the cloud-based system, and that's based in London.
Kialo, do you want to comment? You look like you have a comment.
No, I've just had all of these different interactions with GDPR. I think it's a much more strict regulatory system than what we have in America. For example, we often work with a lot of community deep in the Pacific in French Polynesia, which has a colonial relationship with France. So it's interesting because we're dealing with universities in France instead of what the will of the actual people are in terms of the data. You get what I'm saying? So it's a really complicated colonial relationship, and it affects data governance in meaningful ways. But I think it's really important because you can't just trade people's genomes around like baseball cards. So.
Yes. Great. Do we have someone who can read one of the online questions just to take a break from the in-person to give?
Okay. Sorry. Hi. I have a question from Rohan Bukhar from MGH. And his question is, what are your thoughts on prioritizing for maximizing array and whole exome sequencing instead of whole genome sequencing, since, as per the recent review article from Regeneron, proposes the former choice?
Okay. Whole exome and array versus whole genome, which is so much more expensive?
I mean, if we had our way, I think everyone up here would want long read, high depth, you know.
I think really depends on your available budget. If you can do whole genome sequence, but if not, as an interim measures, do genotyping. That's still very informative. Yeah.
Yeah, our experience was also that genotyping with imputation with a population-based reference panel actually in many places was even better than exome sequencing. But if you're looking for rare variants, of course, go for exome sequencing.
I was just going to say that it depends on your purpose. If you want to do a polygenic risk score, genotyping array would be great, right? But if you're looking for rare variants, the gold standard is whole genome.
Yeah, I mean, we've done it all, the genotyping and imputation, exome and whole genome. And you're absolutely right, it does depend on what the end research analysis is. But even with whole genome sequencing, it picks up more variants in the exome than exome sequencing does.
Right.
So it really depends.
Okay, another question.
Thank you all for your inspiring discussions. So my question is that what is your vision towards the next generation biobank development based on the development of Internet of Things technology, wearable and implantable devices, and blockchain and digital finance technologies?
Great question. I personally think that the future will be decentralized. It will be a kind of constellation or a federated community of smaller biobanks that are distributed in community, rather than concentrating all of these resources in places like Cambridge, La Jolla, the Bay Area, etc. I think that's a more democratic approach. Imagine each federally recognized tribe in America has their own access point, and and we can play some really beautiful perspectives out in terms of data sharing and that approach as well.
I think the best strategy is to enrich and harvesting the existing biobank, because it's been a long game, 20, 30 years to get study established, linked with the follow outcome, and now technology is getting there. So this requires global effort to analyze. There's a huge, rich, data as well. If you start some new biobank, you're not going to get any informative findings, at least for 20 years in our experience. So I think that's probably, you need both, but I think you need to prioritize. I think for us, I hope Naomi will agree, the key things is actually turn sample into the data and also make data more widely available to address all kind of research questions. I think this is a good mind. We shouldn't just jump into the new studies with ignoring existing studies as well.
Naomi?
I think the key thing for the next few years, and I'm talking to all the students in the room here, is actually we need a generation of people who can analyze all this data.
Right. Data scientists.
It's so complicated. The sequencing data, the multimodal imaging data, the electronic health records. You need a multidisciplinary team, and you really need bright young minds of today who can really make informative findings from these data, because it is just so vast and so complicated now.
Wonderful.
Hi, thank
Young
you.
person at the right mic.
Yeah, thank you all. And I have a, excuse me, I had a very similar question to the previous one, but I had another one for Kiolo, if that's okay, but anybody can also jump in. I think that it's amazing and great that we are working towards diversifying the samples and the data that we are, but I think that we also need not only their data and samples, but also their ways of knowing and their knowledge and their wisdom. And so I would like for you to comment a little bit more on what Indigenous Futures, for example, is doing in this particular context, like in this particular area, on how are we diversifying our methods, our ways of doing and ways of knowing with the wisdom with ancestral wisdom. And if you know of any banks in Latin America as well. Thank you.
Yeah, I'll just respond directly. So we have a whole institute, the Indigenous Futures Institute at the University of California, and a lot of the questions that we are prioritizing have to do with that, like connecting remote sensing data with indigenous knowledge on where controlled burns should be for the climate crisis, things like this. In the genomic space, there are some really elegant examples of this. Family-based pedigrees or genealogical research that communities are doing to identify different diseases. In 1998, there was a great example of a gastric cancer gene that was identified in the Maori community, and they went directly to their local university, and it was in Nature. They included multiple people from the community, nurses and orderlies in the author list in Nature. I think that's a gold standard for everyone here at Harvard and University of California, Stanford, et cetera, should be doing in terms of creating currency for participants. And then, yes, I have some great friends in the FA Mexico City who are working on some incredible projects, Santiago, Chile as well. I'm happy to talk about that afterwards.
Wonderful. We just have time for one more question because lunch is waiting for everybody. So I'm sorry. I know there are many more, but the speakers will be at lunch, hopefully, so you can talk to them there.
So first of all, Hanno Steen, Boston Children's Hospital, and I would like to thank all the speakers and panelists for this very interesting discussion. So what I would like to address is a little bit this disconnect between the first keynote lecture and then the panel discussion, that in Uganda or in Africa in general, they couldn't distribute the mRNA vaccine because they were lacking the cold chain. We're talking about biobanking. What I'm missing is a little bit, how do you biobank in a country where you have basically, where resources are limited, where you don't have freezers? And I think that's really a little bit limiting also, especially then also with the local engagement and so on. So my lab, we have analyzed samples from Papua New Guinea, the Gambia, Guinea, and so on. So there was always that, in most of the cases, a former colonial country still has some research station there, and they collected or organized a collection, and then was always, who owned those samples? Who had the and I think that's really also a little bit the disconnect. And also along those lines, and Dr. Fox already is getting ready to answer, I think a lot of the biobanking is a little bit too much focused on genetics and genomics. There's so many other omics out there which can actually do a lot of work on dried blood spots, dried urine spots, and so on. And I think those things should also be considered. We should actually, I think, distance ourselves a little bit from the genomics and genetics. Thank you very much.
Just to answer your first question, shipping containers. Shipping containers are going to deliver us to that position. Moderna and BioNTech are already doing this to eliminate the cold chain for these mini vaccine mills. That's been our approach with decentralization as well.
And generators?
Generators, shipping containers, renewable resources like solar, just to keep it a circular system. Africa, like Nairobi, is so far ahead of the rest of the world in terms of thinking about these things. And it's just super inspirational. And then the second one was about, paper-based diagnostics. I love them. They're amazing, and I think there's a whole institute here on that, the Wyss Institute.
Right. On the technology. Go ahead.
Yeah, very briefly, I think the genetic, because the technology is ahead of others, so other things are coming. Proteomics, metabolomics, they're really powerful, especially proteomics. In terms of, aging clock, risk prediction, they're far and outperform in a lot of polygenic scores. So they're coming.
So for the next conference and future conferences, we'll have a lot more to discuss. Thank you very much, everybody.
Thank you, everyone.